any type of defect which is appear on the plastic component after the production, right? So it is known as molding defect, right? So basically it is molding defect, you can say that it is about the product quality issues, right or wrong? It is product quality issues, है ना, from the molding technology, है ना, when you uh, uh, when you produce the component from the injection mold, right, by the IAMM, injection molding machine, right? So it is all about the we are trying to control the plastic component in quality, right? And dimension accuracy should be satisfied depending upon the customer requirement, right or wrong, or the application of the component, right? So as I told you about the application should be satisfied, right? Okay, so which is also depending upon the dimension accuracy, right? Male or female part or like this, right? Okay,
Yes.
so maybe molding defect may be related to this category, like appearance, like dimension accuracy, like application should be satisfied from the customer, and right. Okay, so you can see that quality issue in injection molded product can range from minor surface defect to the more serious problem, like uh, can be affected the safety performance or the function of the product, right? Okay, so but this type of defect or this type of problems we can you can say that we can control by the molding process, by the injection molding process, by the material use or the tooling design. So basically this is the combination of these three things, right or wrong? If the defect is produced into the component, so basically this is the, you can say that this is the combination of these three things, right?
That's correct.
Understood? Like molding process, है ना? So basically during the molding process there is some parameters, right, which we have to use during the molding, right? And the material, so it can be related the MS or the tooling material, or it can be related to the plastic material which we are using for the raw material, right? Or tooling design, so basically we are dealing with the tooling design, है ना? So depending upon that tooling design, mold will be manufactured in production department, right? Okay, understood. So basically what are the common molding defect? Generally if we see the component, so what are the common defects? Like flow lines, burn mark, warpage, है ना, flashes, vacuum voids, sink mark, weld line, short. These all are the defects which can be produced on the component, है ना, or in the component, right or wrong? Understood? Okay. Okay. So we can you can see that we can control that this type of defects by the molding process or by the CAD design. Okay, CAD design we can control, or by some molding, or by changing some parameters, right? Okay, but how? See, है ना, so we can avoid this all type of defects. See, you can typically avoid this defect relatively easily simply by adjusting the flow rate, है ना, temperature or the pressure of your mold, है ना. What is the meaning of pressure? I'm talking about the injection pressure, right? For example, if we are flowing the material with a higher pressure, so maybe it can be produced some type of defect into the component, right or wrong? If the pressure is high, or if pressure is too low, so maybe it will become a cause of any type of defect, right or wrong?
Yes, correct.
Okay, so basically like flow rate, right, like mold temperature, so we can increase or decrease depending upon the material or the property or the application, right? Okay, and we can change into the part design also, है ना. What is the meaning of if we can change the part design? Means changes in design or the component design, we can say that, right? So if, for example, if we have a component like this and there is a feature into this component, right, or if this feature has no requirement, okay, so we can remove this feature, in order to remove the defect, in order to avoid the defect. Is it clear? Right? So by adjusting this type of points like flow rate, molding temperature, injection pressure, or the part design change, or the mold design work, which is the last one. Okay, mold design work, which is the last one. Okay, which maybe go into the revision, right or wrong? Okay, understood,
Yes, sir.
right? So I hope you understood about the. So basically, it is related to the quality CAD design, and by the control system we can adjust. We can adjust these parameters, and we can avoid the defects. Right? Okay. See the one by one, all the defects and the what are the appearance of that and the causes and the solution. Right? Okay. See here. So flow lines, basically it shows a wavy pattern, often a slightly different color than the surrounding areas, right? Okay, so generally on narrower section of the molded component it will be show, right? Okay, what is the causes of that? A variation in the cooling speed of the material. Acha, how it can be happen, or how it can be occur into the molding process, during the molding process, ki that variation in the cooling speed of the material, how? Tell me. How it will be occur into the molding process? I am asking to you. Tell me.
No idea.
For example, like this. For example, I have a runner like this. Huh? I have a runner, and I am preparing another sub runner. Another sub runner. For example, from this point to this point, this distance is around 50 mm, right? And from this point to this point, it distance is around 50 mm. How much? Achha, understood or not? What you are preparing here? What you are preparing? Tell me. You are preparing a runner. This is the runner. This is the sub runner. Where you are going to feel these components. These components. For example, from this section, from this main runner. For example, you are flowing the material about 10 units. How much? 10 units. Diameter of this runner and the sub runner will be same. For example, right? Like for example, 10 mm diameter for the main runner and the 10 mm diameter for the sub runner. The diameter will be same, right? For example, diameter is same, right?
Okay.
If you are flowing the 10 units from this main runner, है ना? So basically, what happened here?
It will share to the both.
But what is the difference between both flowing into this sub runner and the flowing into this main runner? Flow speed will be less here, right? Compared to this.
Yeah, flow will become less.
Flow will become less. Why? Because the diameter is same. And what happened here? Here it will go the 10 units, and here it will go the 10 units. That's why, right? Okay. So because of that, for example, if the velocity decrease here, and so because of that, flow lines will be occur. Maybe there is a possibility of that. Is it clear?
Yeah. Okay.
Okay. Because there will be the cooling variation. Why? Because of the speed, cooling will be higher, and here cooling will be less. Right or wrong? So we cannot provide the cooling lines all the time uniform. Right or wrong? And that's why. And variation in the cooling speed of the material, or if we are providing the non-uniform cooling into the core and cavity, right? So it will become a cause of that, right? Okay, and again, difference into the wall thickness. For example, you have a component like this. See, okay. So for example, you are preparing, or you have prepared the component, okay, but you have to prepare some few rib and gussets into the components, right or wrong? Okay, so there is a possibility of the non-uniform wall thickness, right or wrong? Like into this area, right? So sometimes we cannot control the wall thickness into the component, right or wrong? So maybe difference into the wall thickness, it will be occur. This is the requirement of the customer, right? Or the component. So that's why wavy pattern will be occur there, right? See, so what is the solution of that? If we want to avoid or remove the wavy pattern, so basically we have to increase the injection speed. And we should increase the injection speed or the injection pressure, right? Or the material temperature. Slightly we have to increase this, right? To ensure the material fill in the mold before the cooling. Before cooling. Right? Wavy pattern look like this. See here. See. Understood or not?
Yes, sir.
See. है ना? Again. See burn marks. How burn mark will produce? Tell me. Okay. So just for an example. Acha. We are dealing with the plastic material, right or wrong? Right? We are dealing with the plastic material. है ना? If we burn, or for example, if we melt the plastic material, basically it will produce the gases, right? It will produce the gases,
Yes.
right? If it will produce the gases and you are injecting the material from this side into the component, so basically material will be go like this, right? In this direction, right? Material will be go and the gases will be pushed into this direction, right? Okay?
Yes.
Okay, for example, this is the last point of the gas. है ना? Gases will be here. है ना? And for example, again I'm applying the injection pressure from here of the material, है ना? Of the plastic material, right? So basically gases is here right now. Okay, so here pressure is applying again. Okay, so because of the increase in the pressure, temperature will be increased here, right? Of the gases. So that's why basically these gases will burn the component. Because for example, if you increase the pressure, the temperature will be increased, right or wrong? Like pressure cooker. Right or wrong?
Yes, sir.
Because of that, this gas is burn the material. So basically burn mark, you will appear into the component at the end of the component, you can say that. For example, if the gate location is here and this is the end of the component, so basically you will find the burn mark in this location. Is it clear?
Yes.
Always, right? So, what is the reason of that? As I told you, gases. Trapped gases into the component, or the impression, you can say that. So burn mark typically appear as a black or the rust color decoloration or an edge or the surface of the molded plastic part, right? Causes trapped air or the overheating into the mold cavity during the injection. Maybe this is the cause of that. If we are overheat the material, so because of that trapped air or the gases will produce the more temperature there, right? Right? First causes the trapped air and the overheating into the mold cavity during the injection, right? And what is the solution of that? Lower the melt or mold temperature to prevent overheating. Is it clear? Lower the melt or the mold temperature to prevent overheating. One more solution is that reduce the injection speed to limit the risk of the trapping air inside the mold. Reduce the injection speed to limit the risk of trapping air inside the mold. Understood or not? Acha, one more solution you can take here, that you should use air vent into the mold in cavity section. Is it clear? Air vents. If we use air vents, so basically air will be escape or the gases will be escape from the events. Right or wrong? So
Yes,
burn will not produce there, right? So this is the one of the solution of that. So we can use this, but this is very important, right? Okay. Basically, after the trial, a customer show you the photos of the component, for example, right? Or the component customer shows you component, right? That this type of defect produced into the during the production, right? So basically, we have to give the solution to the customer about that, right? So these all are the solution, which is very important. Right or wrong? See, this is the burn mark. So basically, it will burn as I told you, right? Okay, so it will look like this, like black spot here, right? Understood? Acha, one more thing is warpage. What is warpage? Warpage is nothing but, acha, tell me what is the warpage? It is related to, warpage is related to shrinkage, right or wrong? Hemant, right?
Yes, yes, yes.
Warpage, or the warpage is related to the shrinkage, you can say that. Every material shrink during the cooling, right? है ना? Is it clear? See, so basically plastic or the other material can warp during the cooling process. When uneven shrink put stress on different areas of the mold part. Okay, so this stress result in bending or twisting of the plastic part, है ना? Or the finished product, है ना? Basically it will twist the component or the, so what happened there because of that twisting or the bending. For example, you have a component like this and you need this dimension around 200 mm, and because of that unwanted warpage, what is happening here, that you will get about 198 mm. You are getting that 198 mm. So basically it will affect the dimension accuracy, right? It will affect the dimension accuracy. Understood or not? Right? Okay. What is the causes of that? Uneven component wall thickness, right? So warpage is one of the defect which we have to control into the component, right? If we have a big or the big volume component, so we have to control this warpage. This is very important, right? So uneven component wall thickness, okay, understood, and uneven cooling of the plastic part. Uneven cooling of the plastic part. Is it clear? So this is the main cause of that, and which sometime which we cannot control. Sometime which we cannot control. Understood or not? You cannot provide even, or you cannot provide the uniform cooling into the mold always, because depending upon the component geometry we cannot provide the uniform cooling for the core and cavity. Understood or not? Okay. And it is also depending upon the wall thickness. So sometimes we cannot control the uniform wall thickness into the component. So basically this is happening to the component always, right? Understood or not? Achha, what is the solution for warpage? Cooling should be uniform. And we can try to provide the cooling into the mold, to uniform cooling to the mold. But right? And one more thing is how we can, for example, we have a component like this. Okay. For example, I want to control this dimension. And I want strength into the component also. Okay. So for that, I will use a rib or gussets. For example, this is the rib and gussets. For example, you can find this type of rib or gussets in any type of container, right? Food storage component, like for example, you have seen that carrot of tomato, right? So in that carrot you will find lots of rib and gussets, right or wrong? In order to provide the strength to the component as well as reduce the warpage defect, right or wrong? Tell me.
Yes, correct.
Right? So basically, one more solution is that for the warpage, that redesign the mold with uniform wall thickness and part symmetric, ensure the greater stability in the part during the cooling, or we can use the rib and gussets for providing the strength to the component and for avoiding the warpage. We cannot eliminate the warpage from the component. Is it clear? Like this, see here. This is the warpage. See? What is happening here? See? Basically, see what is happening, right? See here, right? Understood? So that's why, okay, flashes. Achha, what is the appearance of the flashes? The flashes is the molding defect that occur when the submolten plastic escape from the mold cavity. Typically, route of escape all through the parting line, right? So basically here I am talking about the escaping of the material from the parting or the parting surface, right or wrong? Okay. है ना, excessive injection pressure may force the plastic out through the route of least resistance, right? See here, what is the main cause of that? Injection pressure is higher than the clamping force. Maybe it is possibility, right or wrong, that the injection pressure is higher than the clamping force. Our calculation was wrong. For example, our calculation was wrong about the clamping force. Maybe it is possibility, right or wrong? And one more thing is that material has a lower viscosity. Material has a very lower viscosity. So this is the main cause of that. Maybe possibility, right or wrong, of the flashes. Okay. So what is the solution that it provides? First of all, we should provide the interlock for the impression. Okay. For ensure that the core and cavity will be matched together in a proper way. Right. This is the very important. Is it clear? And your we should check the clamping force against the injection pressure, that it should be higher than the injection pressure, right or wrong? This is very important thing. And one more solution is that replace the component material with high viscous material. For example, if the flashes occur into the molding process, right? So what you can do there? What you can do, for example, if this is lower viscous material there, right? So basically in lower viscous, for example, you have a PP material, and which is the homogeneous, right? Which is the pure material, right? So in PP material, you can add the 10% GF material. 10% GF, this is the glass fiber material. So because of that GF material, its viscosity will be increase, right? Understood? Okay. So this is the solution for the flashes. If the flashes occurring into the component or during the production of the component, so basically we can provide this solution. Understood? Okay. So here, this is the flashes. If the flashes occur into the component, into the molding process, so basically we have to remove by the cutter. So basically it will become the post process. So if we have to, for example, if we are dealing with the post process with the component after the production of from the injection molding machine, so understood? So then what is the use of the injection molding process, right? If we have to go for the post process, right? So that's why flashes should not be there, right? So this all are the solution about the flashes, that provide the interlock for the impression or replace the component material with higher viscous material, or we should add some few percentage of the GF material into the plastic component in order to increase the viscosity of that, right? Okay. Chalo, vacuum and voids. Tell me, vacuum and voids. Vacuum or voids is nothing but it is like a bubbles. It is like a bubbles into the plastic component. For example, if we have a transparent component, so basically it will appear into the component. Or if we have a colored component, so it will be not appear there, right? Vacuum voids it is directly related to the burn mark. You can see that. What is the reason of that? Vacuum voids or the air pockets are trapped air bubbles that appear into the finished molded product. So quality control professionals typically consider voids to be minor defect, right? Why minor defect? Because it is related to the color. For example, if you have a transparent component, so it will be show. But if you have a colored product, then it will not appear there, right or wrong? That's why. Right? What is the cause? One of the chief cause of the voids is inadequate molding pressure to force trapped air out the mold cavity. Solution: choose a grade of material with lower viscosity to limit the risk of air bubble forming, right? And provide the air vent into the cavity portion. Is it clear? So bubble, we can avoid the bubbles, right? See here, this is the transparent component or this is the colored component. See here, you can see that here. See, this is the bubbles, right? And
It is similar to porosity in casting. Right?
Yeah. Similarly, so very similar to if you are dealing with the HPDC, so there we will use the term porosity. And here in the, if we are dealing with the injection molding process or the plastic component, so basically we will say the whites, whites or the bubbles or the air pockets, right? Okay, so here you can see that into the transparent component it is visible, and the colored component it is not visible, right? Okay, sink mark are nothing but are the small recesses or the depression on the surface, है ना? So what is the reason of that? I'm showing the appearing right now. See, pulling material from the outside inward, right? See, what is the cause of insufficient cooling while the part is in the mold? Insufficient cooling, right? Okay. Acha, what is the reason of that? For example, you have a wall thickness of the material like this, है ना? Like this. Okay. For example, this acha, here you can see that this section has a higher wall thickness, right or wrong? Right or wrong? Okay. For example, understood or not? This area has been cooled. This area has been cooled. This area has been cooled. But into this section, you can see that this area is not cooled into this. So basically, this is into the melted condition right now. Inside the section, I'm telling you. So if this is in melted condition, so basically it will shrink, right or wrong? It will shrink during the cooling, right or wrong? So that's why basically it will pull the material like this. It will pull the material like this. So that's why pulling the material from outside inward, right? It will pull the material and it will create the shape like depression or the recess. Understood? And one more reason is that, for example, we have a component like this, and here this is the air trapped air, for example. So what is happening here during the cooling? So basically this trapped air try to pull the material like this during the cooling. Try to pull the material like this. This is the reason of that sink mark. So what is the reason? I am showing you about that. I have shown the two diagram about that, right? So tell me, what is the reason of that? Uneven wall thickness, right? Insufficient cooling while the part is in the mold. So basically one of the reason is that it may be reason that uneven wall thickness, right? So sink mark can also be caused by the low pressure into the mold cavity. This is one of the reason of that. So what is the solution of that? Increased cooling time. Quite. And so basically there is a solution depending upon the defects, right? Understood or not? To increase the cooling time to limit shrinkage and design your mold with thinner component wall thickness, right, to allow the faster cooling near the surface, right? Okay, understood or not? This, see here, this is the sink mark, right? This is the sink mark here. Acha, weld line. Acha, what is the reason of weld line? If the material comes from the two direction, right? So basically it will like a, for example, splitting the part. It will create a line between the component, right? So you can say that here like weld line is a result of weak material bonding, you can say that, right? Acha, hai na? Which lower the strength of the part, right? What is the cause of that? If the temperature is not enough high, it may lead to the premature solidification of the molten plastic, hai na? Or it may be caused, for example, you have a component like this, and the component has a feature like this, right? And you are injecting the material from this direction. So basically it will create a direction like this, and so basically here will be the welding line, right or wrong? So it may be caused by the depending upon the component geometry also, right? Okay, understood?
Yes sir, yes sir.
Okay. So if the temperature is not enough high, so it may be lead to premature solidification, as I told you. And now what is the solution? Redesign the runner or gate, right? For example, we have a component like this, okay, and component has a feature into the like this, right? So basically we can use this type of runner like this, है ना? We can use this type of runner like this, है ना? So I am feeding from this direction and from this direction, right? Or if for example if we have a component like this, right, and feature like this is the hole here. Okay, so here we can use a disk gate system. What we can use? Disk gate. So basically I will inject the material from this center point, right? And this all are the gate. What is this? Edge gate. So basically it will provide the uniform flow, right or wrong? So there is a less chances for creating the weld line, right or wrong? Understood? So redesign the runner or the gate system. This is the solution of that, right? And try to provide balanced gating system, right? Understood?
Yes, sir.
Here you can see that what is this, right? This is type of weld line, eh? You can say that, but this is not a weld line right now, eh? I'm just showing you this is the type of weld line, and so this is the parting line here I'm showing you right now, right? Depending upon the component geometry. Okay, so here you can see that there are two types of lines into the defects, right? One is the melt line, and one is the weld line, as I told you, right? Acha, what is the difference between both melt line and the weld line? Tell me. Here, this is the two figure here. See. Weld line, you can see that weld line is provide the, tell me, lower strength, right? 1 minute. Tell me, right? Or the weak material bonding, you can say that, है ना? Weld line, है ना? I am showing you the weld line right now. And what is the melt line? It has you can say that it has a mark of the weld line or type of weld line, but it has a strong bond, right? This is the difference between both. As understood or not? Tell me.
Both are weld lines, right?
Both, yes, but
weld line forms has more strength
yes,
compared to weld line forms.
yeah, because for example, if a weld line is producing there, so basically it can component can be break from the weld line during the operation, but melt line has a strong bond, you can say that, into the surface, right? That's why this is the main difference into the both, and so basically we have to predict this type of weld line or the melt line from the software, right? We should predict from there. That's why. Achha, short. I think this is the last one. Short. Tell me, what is the appearance? Molten material does not completely fill the cavity in the mold. है ना? What is the cause? Flow restriction resulting from narrow or block gates. This is, for example, we have a component like this and lots of feature is there. Here. This is the lots of features, right? And you are providing the edge gating from this point, right? So maybe possibility we have to provide the more injection pressure there, right? Okay, but there is a less possibility that confidence of filling of that component, right? Depending upon the flow restriction. This is the flow restriction, right or wrong? So it is depending upon the component geometry also. And a short problem. And one more is that material is too viscous. Material is too viscous. Okay, or mold is too cool. Mold is too cool. है ना? Solution, increase the injection speed, or increase the injection speed, right? Or replace the material with lower viscosity. This is the main solution, right? If we have a short problem. Achha, what do you mean by short problem? You understood about this? You can say that incomplete filling of the cavity, right? Incomplete filling of the cavity. Huh? This is known as short problem. This is the main solution which you can provide to the customer, right? है ना? And improve the runner of the gate system, right? See here, see, this is the part with the short. See here, understood? है ना? See, because of the high viscosity. This is happening here because of the high viscosity, na? See, so you can see the component all around you, right? And try to find molding defect, है ना? For example, if you have a component, you can find the weld line there, and you can find any type of defects into the plastic component, right? You can see that this type of defects, right? So you will have a good practice about that. So you understood about the defects which I have covered right now. You have a idea after this lecture that what is the defects and what are the solution, and what is the appearance of that type of defect, right?
Yes.
This is very important, right? For basically it is depending upon the qualities, quality issue of the product, right? So that's why this is very important. Flow lines, burn mark, warpage, flashes, vacuum void, sink mark, weld line, short. This defect is very important, right? Okay. So, acha, what about the practice? What are you doing? You are doing practice or not? Tell me. Practice.
Yes, sir, we are doing
Okay.
practicing more.
Okay. So in next lecture, which will be on tomorrow 8 p.m. right? Okay. I will cover the DFM report first of all, है ना? First of all, I will cover the DFM report. Then we will go for the multi-cavity mold, right? है ना? DFM report is very. अच्छा, we have covered the DFM report right now. Sorry, we have covered the DFM report in previous lecture or not?
No.
Right. Okay. So during tomorrow lecture, we will cover the DFM report, and we will see a DFM report for the two type of component, right? And we will see the feasibility or the DFM report for these two components, like part A and part B, right? So you will get some idea about the DFM report regarding the mold design, regarding the mold design. Is it clear? Okay, understood? Yes, if you have any question,
Yes, sir.
if you have any question, query about this, that flow lines, burn mark, warpage, flashes, vacuum void, sink mark, weld line, short, so you can ask to me. If you have any question, query, tell me. Tell me, jaldi. 855. No question? You understood all the points? Hemant, understood all the points? So there is no question query. Okay.
There is one doubt I have.
Yes. Tell
There
me.
are two defects which is because of the viscosity cause.
Yes.
What is the main difference between the short and one more we have seen, no? Sink marks or flashes, I don't remember. Weld mark.
Sink mark, basically it is related to the wall thickness, right? For example, if we have a component and has a wall thickness like this, and here, for example, here is the wall thickness like 2 mm, here will be the wall thickness for 3 mm, and this is the 4 mm. So what is happening here because of the so basically sink mark is you can say that sink mark can be related to the porosity, or you can say that voids, right? Okay, so if the wall thickness has into the component, there is a variation of the wall thickness, right? So that's why sink mark will be produced there. And where it will be produced, for example, like this, we have a component like this, right? So here you can see that this is the variation of the wall thickness, right? Indirectly you can say that wall thickness is the same, right? Here you can see that into this component, this is the radius here, this is the radius here, right? So but indirectly it will become a large wall thickness into this section, right or wrong? So that's why sink mark will be produced during the cooling, because this will cool the rapidly, this will cool the rapid, and this will cool the rapidly, and inner portion of this section, because of this section it will produce a sink mark.
Oh, this I understood.
Yeah.
There's one more defect which causes the lower viscosity of the
Yeah.
material, other than short shot. So, what is the main differences between short shot and the one more defect? The one more defect, which also is the reason for lower
Yes,
viscosity.
because of the lower viscosity, right? Whites, so whites has a solution of lower viscosity, right? And the short shot also.
Yeah, flashes and short shot. Correct.
Flashes or the whites? Not
Flashes, not whites. Flashes.
flashes. Basically flashes. What is the flashes? Tell me first of all. Escape the molten plastic from the cavity section, right? This is known as flashes.
Okay.
Okay, so what is the reason of that? For example, you have a component, 1 minute, like this, like for example, we have a mold like this, okay, like this, okay, and here you can see that this is the cavity section, and you are providing the injection pressure from here, right? So basically, what is happening here, during the pressure, for example, pressure is applied here, right? So for example, if the clamping force is lower than the injection pressure, this injection pressure, right? So basically it will jump the mold, it will quite jump the mold, and it will create the flashes. Understood? Basically it is not, for example, it is not clamping the mold in proper way during the injection. It should be proper clamped, right or wrong? But if the injection pressure is higher than the clamping force, for example, if a quite, for example, like 0.1 percentage, is higher than the clamping force, so what is happening here? Basically it will create the jerk here, right or wrong? So that's why material will be come out from the parting line.
Oh,
है ना?
okay.
Like for example, like for 1 second, or you can say that 1/2 second, you can say that, right? 1.5 second. So basically it will create the flashes. It will escape the material from there. है ना? And one of the reason is that, for example, you are creating the vents there, है ना? Vents there, है ना? And you have created the vents depending upon the PC material. Because PC has a higher viscosity material, right? PC is the higher viscosity material. And you are using the PP material, for example, right? So basically, if you have prepared the air vent depending upon the PC material, so if you are using if customers use PP material, so what is happening there? It is the less viscous material, and it is the higher viscous material. So because though basically PP will escape from the air vents, and it will create the flashes. This is one of the reason, is there, right or wrong? So that's why I have told you that with the PP that you should use the few percentage of GF material. If you increase this, then it will become high viscous material. That's why it will not produce flashes there, right? That's why. Understood?